Scientific notation. Why are quantities represented in multiple ways? Well, the reason is because we need to use them differently. In scientific notation, that helps us to talk about real world quantities, whether something's very large or something's very small. There's a great video out here, that's why I've checked this out. There's a great video out on YouTube that let me show you really quick here. It's called, oops, let's shut that down there. It's called The Powers of 10. And if you go onto YouTube and search Powers of 10, and it talks about how something very large and very small, what the relationship is, and how scientific notation plays a part in it. Now, let's kind of take a look at it on a smaller scale. We'll look at it here with using 10 to the third. So 10 third, 10 to the squared, 10 to the first, 10 to the 0, 10 to the negative 1, 10 to the negative 2, and so on. So we know 10 to the third power, which is 10 times 10 times 10 is 1,000. 10 squared, which is 10 times 10 is 100. 10 to the first power, which is 10. And 10 to the 0, which is 1. We know that 10 to the negative 1 is 1 over 10, which we could write as 1/10, like so. 10 to the negative 2 is 1 over 100, or 1/100th. And 10 to the negative 3 is 1 over 1,000, or 1,000. What do we notice is with the exponents is that when we have positive exponents, we tend to have larger numbers. When we have negative exponents, we tend to have smaller numbers. And you can see that relationship. As it's got negative, we started our numbers to get smaller and smaller. As these numbers grew, as a positive exponent, our numbers got larger and larger. So if we take a look at a number, standard notation, 2,300, and compare it in scientific notation to 2.3 times 10 to the third, we can take a look at some things and decide how our setup should be to take a number to move it from standard notation to scientific notation. For example, the decimal is behind the first integer single digit. Now, when we say single digits, we're talking numbers 1 through 9. 0 is not going to count as our integer that we're going to use. Even though 0 is an integer, we're not going to use it as part of our scientific notation definition. The remaining non-zero numbers are going to follow behind the decimal. So we can see that the number 3 is used. That's going to follow these extra zeros. This is where scientific notation comes in. We get to drop those and not use them in the decimal part of scientific notation. Then we're going to multiply times 10 to the power, moving the decimal back into standard notation. So for us to go from 2.3 to 2,300, we would have to move that decimal 3 places to the right. And because we're moving it to the right, because this integer here is positive, and because it's positive means that we have a large number, so we'd move the decimal from right behind the 2 to the right to make it larger. If it was negative, we'd go in the other direction. So let's kind of practice a few of those to see what I'm talking about. Here I have the number 4,240,000. Following our steps, we would keep the 4, write a decimal, and follow with the non-remaining zeros, which would be 2, 4. We wouldn't need these zeros here. We're going to multiply times base 10, and now we need to find our exponent. We know this is a large number, so our exponent will remain positive, and we'll count 1, 2, 3, 4, 5, 6. It'll move 6 places to get into that spot, so we'll end up with 4.24 times 10 to the 6. Looking at another problem here, example number 2, I have 300,800. Following the same idea, we're going to use the 3, which will be our number in front of the decimal. Now these zeros we're going to need to keep because they're placeholders. We notice that the 8 is 2 away from the 3. So in order to maintain that 2 away from the 3, we're going to have to keep those particular zeros. We won't be keeping the ones on the end. We're going to multiply that times 10 with a base of 10, and their exponent that we're going to look at, it's going to be 5. 1, 2, 3, 4, 5 will get us right back into the right spot. Taking a look at one more. Here we have 5,983 10,000ths. So taking this number and rewriting it, we would have 5.983, and we'd multiply it times our base 10, and our exponent, because we want to move it just one place, would be 1. But because this number is small, and we're moving to the right, we are going to make it negative 1. Now let's take a look at some numbers that will move from scientific notation into standard notation. Here I have the number 1.99 times 10 to the negative 5. What we're doing is taking 1.99, and because if this is a smaller number as designated by that negative 5, we're going to move that decimal to the left 5 places. Now we move it 1, which is fine, but we're going to have to add some zeros to keep going. So 1, 2, 3, 4 more zeros so that it moves 5 places. In rewriting this number, we'll put a 0 in front of the decimal to be deliberate, to show that our decimal is meant to be there, and then add our numbers. Doing it one more time, 3.65 times 10 to the third. This is a large number, so again, we're going to take that 3.65 and we're going to move it 3 times, and we're going to move it to the right because we want it to be larger than 3 and 6500ths. So 1, 2, and we'll move it 3 more. 1, 2, 3, that'll make it, oops, I'm sorry, I got carried away there. I apologize. I was thinking 5. We're going to move it 3 places, so 1, 2, and we'll move it just 1 more, which will give us a 0. So our final answer then will become 3,650. Now, taking a look at format, we want to know if this is correct. 35.4 times 10 to the third. We know it's not because we only need 1 digit in front of the decimal place. And because we need to move it over 1 more place, we need to get it over 1 more time. We're going to put it 10 to the fourth. Now, how do we know this for sure? Well, let's take a look at what 35.4 times 10 to the third is. If we move it those 3 places, we can see that we get 35,400. 35,400 would require us to move it over 4 places to get in that spot. One last time, 0.038 times 10 to the negative 2. Again, this has a 0 in front of the decimal. We need to get a non-zero number, so we're going to put that 3 in front, so 3.8. And again, we're going to think about what number goes here. It's going to be negative 4 because we need to move 2 to the right. Well, again, if you're not sure what that looks like, we can show you. We can start out with 0.038. And if I'm going to move negative 2 times, 1, 2, this is what our number really looks like. And for us to get it all the way over here, we need to move it 4 places, which takes us back there. Hopefully this will give you a better understanding of scientific notation, how to use it, and how to go back and forth between standard notation.